You know how it is. You buy one cute little module and then think, it looks lonely, I'll get another. Before you know it, you've got a lot of cute little modules. Actually, all that's been happening is that every time I place an order on AliExpress, I forget that I've already ordered some of these modules and add another one to the basket, as they are crazy cheap. So it's time we put one of these boards to work and did a little project. But let's take a look at one under the microscope. I have been burnt recently by dodgy soldering on cheap things. Now, as always, this video is sponsored by PCBWay. We've used them for a lot of PCBs now, and they've been great. There's a link in the description. So here's the brains of the operation, an ESP32C3. Now, looking at the code, it's got built-in flash, it's high temperature, and there's 4 megabytes of it. So that's pretty decent. Here's the 3.3 volt regulator. Do the old solid check, so it seems like it's nicely soldered on, can't see any issues there. It's a pretty nice board really, it's quite nicely designed, looks quite clean. The antenna is this ceramic jobby on this side, so that's the antenna here. Now I have read a few people saying that these little tiny, very compact boards, you don't get much Wi-Fi signal on these antennas due to the placement of them being a bit too close to the buttons and stuff. So we'll probably try and avoid doing any Wi-Fi work with this board for now, but let's try and think of a project we can do. Now, one thing that I have got, I have this quite nice heart rate and blood oxygen monitoring module that I got in the recent AliExpress unbagging. So this is a Max 30102. It's pretty interesting. So on this board, we do have a variety of things. So let's just get focused. So the first thing to note is we have this 3.3 volt regulator. This is a little boost IC. You can take a variety of voltages in and gives 3.3 volts out on this pin. Seems to be pretty solid as well. Do the old solid check. And then there's also a 1.8 volt regulator here. Now I have read a few things where some people have found that actually this is a 2.8 volt regulator rather than 1.8. Pretty important that it is correct. Now I've checked the voltages on this and it is fine. But the really interesting thing on this board is the actual sensor. So let's zoom down on this and have a close inspection of it. So this is really interesting. So on this side here, through this window, these are actually two LEDs. So this bottom one is a red LED, and this top one is an infrared LED. And then here we have a sensor and a whole bunch of DSP processing stuff. It's interesting, the actual outputs from this device are actually just the value of the red and the value of the infrared. Let's power it on. So I'll just plug in the module. So I've got it powered on. Now you can easily see the red LED, but if I cover this up slightly and just move the lights away, you can see a slight glow from the infrared LED. So the camera on my microscope is picking up the infrared coming out of that LED. So that's pretty interesting to see. Yeah, pretty cool. So let's get it all wired up and see if we can actually make this work. But yeah, that's pretty fascinating to see. So we have the red LED and we have this nice infrared LED lighting up. And then you basically stick your finger on top and it detects the pulse rate using the red LED and it detects the oxygen levels using the infrared LED. Yeah, pretty interesting. But let's try it out, see if it actually works. So the wiring up is pretty simple. So we're going to connect pin 6 to SCL, which should be this one here. Pin 5 will do SDA, so just connect pin 5 over to SDA, which is this one. So that's our I2C connections wired up. This top pin here is the interrupt pin, so that tells us when we've got data. I'll connect that to pin 2, I think. And then we just need power and ground. So I'll power it off 5 volts because it's got a 3.3 volt regulator. So we can connect V5. If I can get that in, V5, and this one there, that's V in. And then of course we need ground, so connect ground. That goes to this top one. So that should be all the wiring we actually need. Let's run the old wire scan, see if it actually detects it. Okay, so I've got the old wire scan sketch here. Let's upload this and see if it actually detects our heart rate monitor, and it should show up. Let's see what happens. So assuming I've got my wiring correct, of course, something should show up. So let's have a look. Do we have anything? Oh, there we go. Oh, perfect. So that's working. So 2 devices showing up. So the reason we've got 2 devices is obviously we have an I2C display and we have our heart rate oxygen monitor. So that's working nicely. So I've got a sketch uploaded here that should be reading from the sensor. You can see it dumping out a whole bunch of stuff on the serial monitor. I've got it hooked up to a nice little display here, so heart rate and oxygen levels. Let's stick my finger on top of the sensor and see if we can get some readings to come out. It can be a bit pernickety about finger placement and keeping it very still, but hopefully it should slowly settle and start producing some results. There we go. Oh, it came and went. Come on, you can do it. Let's try a different finger. Alright, there we go, that's working nicely. So we're measuring the heart rate and we got the O2 percentage. Now let's bring in a commercial one. Plug this in. If I can hold everything still and keep everything in shot. So of course I've moved my finger, and now hopefully we'll see if the measurements actually match up. Alright, so that's it's not too bad, it matches up pretty well. So we're getting a heart rate of around 70 on the C3, matches up to what's on this little monitor on my finger, and we've got 99%, I just lost it. It's quite hard to get your finger on accurately without squishing it on. Let's see if we can recapture it. Had it just then. It was perfect. There we go. So that's it's not bad. Seems to work. Works quite nicely. So the code's on GitHub. Get yourself one of these modules and get yourself a heart rate monitor. And you too can build something that's equivalent of this thing that's very cheap. But it's a fun project. Why not try it out?